Hey guys, what is up? Quackware here. Welcome to the 5th tutorial in our Big Data in the Cloud with Hadoop and HBase. In our previous tutorial, we configured our EMR server with a little bit of hiccups here and there, but we got Maven installed, we transferred data to HDFS, and we created our HBase tables. As you can see, our HBase cluster is up and running. So let's go ahead and write the script that uploads the CSV files we put into HDFS into HBase, and then we can actually run some cool queries on them later. Okay, so as you can see, I've created kind of like a directory structure here for Maven. This is pretty standard. This will be available on my GitHub if you don't want to actually create this structure yourself. We just have a few configuration files here that I've pretty much copied and pasted in. We have our Hadoop assembly, our HBase site, which controls basically all this data. I believe we won't actually be using any of this, but it's just good to have it there if you want to be able to configure any parameters for HBase yourself. And the most important configuration file is this pom.xml, so I'll take a little bit of time to explain it. This basically tells Maven how it wants to compile and package your program that you write. So we are going to write just a simple MapReduce script. Just give it some, normal parameters like our group ID, which is basically like our package name, artifact ID, which is like the name of the jar file that we're going to create, version. The important thing is after we specify how we're actually compiling our jar file, we also want to specify the dependencies that we have. So we need 3 dependencies here. We need Hadoop Common, Hadoop Core, and HBase. So these versions must match what you have on your EMR page. So let me go ahead and bring that up for you. 1 second. So remember when we configured our EMR before, we specified things like, so let's bring this up actually. Just going to clone an old one. So remember how we specified like specific HBase versions that we add? And we are specifying like an AMI version and things like that. Make sure that these versions, like 2.40, make sure that they match the 2.40 here you have, that you have here. Because if they don't match and you try and compile it and run it, you'll probably get some sort of error. Because they're incompatible versions with each other. So that's just pretty important. This file will be available to you on my GitHub too. So you don't actually have to create it yourself. Cool. So let's go ahead and create 2 files. We need a driver for our MapReduce, and we need the actual MapReduce file program itself. So let's go ahead and save driver.java. And let's create another one called HBase Mapper. So driver will just be controlling the execution. HBase Mapper will be actually performing the upload. So let's go and create some boilerplate code. If you're not familiar with Java, sorry, but just like check out a Java tutorial. I'm not going to be explaining like the really basic aspects of it. So let's go ahead and create args. We have to throw an exception here, because a lot of what we're doing with MapReduce requires us to either have try catches around everything or throw an exception. This just makes it a lot easier for what we're trying to do. Okay, so we want to actually pass in data to our jar file. We want to pass in the input path of the CSV file we're trying to parse, and we want to also pass in like an output path where the configured H tables that we are creating are located, which we can then run the bulk upload script on. So what we're writing here isn't actually going to upload it directly into HBase. What it's going to do is it's going to take the CSV files, convert them into a file format that HBase can understand and can easily upload, pretty much exactly how they store the files in HBase. And then we're going to point HBase and say, hey, okay, we have files here that you need to upload into your cluster. It's going to go, okay, great. It's going to grab those files and it's going to upload them like right away. So the process of converting it into this file format is what we're going to do now. So let's go ahead and add some comments. args0 equals input path. args1 equals output path. And we can also specify a table if we want. I believe our table is named fair. So let's go ahead and just do that anyway, even though we have a static table name. It's always good to have it configurable. Cool. And excuse me. let's go ahead and make sure that our package is correct. So we have com.quackware.newyorkcitytaxi.bulk import. This is important if we want to specify this class name. We have to give it the full package name as well. And because of our directory structure set up like this is actually our package name. And then we have a whole bunch of imports, which I'm just going to copy and paste for you. So these are all the things that we're going to be using. If you don't know and you write this code and you don't have these imports, it's just going to throw errors, and you can slowly incrementally add them. This is just to speed up time, just have all these imports in here. Excuse me. So the first thing we need to do is we need to create path variables that HBase can understand, because it doesn't directly read the string, input-output paths. We need to wrap them in a path object. So new path arg0, path output path 1, and let's just label the table name too. Cool. And we need to create a configuration for our HBase. This just sets up, it usually reads HBase site.xml, but I believe if we have the jar file running in our HBase cluster, it'll just read the default configs that we have there. Not 100% on that, someone can correct me if I'm wrong. And let's go ahead and set the table name. Cool, that's all set up. So now we just need to create a MapReduce job, and we need to run it. So let's create a new job, pass in the configuration so it knows where to access HBase, and let's call it New York City Taxi bulk import, since that's the name of it. And we need to set the jar that this job is going to run. So this will be this, oh crap, I just realized I'm writing this on HBase Mapper. So let's go ahead and copy that back out. So we need to specify the jar file of the job we are going to run, which is going to be HBase Mapper. So let's just go ahead and set jar by class, HBase Mapper.class. And we also need to set the mapper class. Again, HBase Mapper.class. And we need to set the mapper output, basically what this mapper class is going to output once from its job. And that set map output key class, the key is going to be immutable bytes writable, which is in HBase terms is the RowKey. And we need to set the map output value class, which is going to be the values, basically the column values, and for that is just key value. And we also have to set what this job is going to be reading in, which is the CSV files. So set input format. In order to specify that, it's just a simple text input. So these things might be a little bit cryptic to you. You can just read into the various Java docs if they have available, and you'll get a little bit more information about what each of these classes mean. Okay, now we can go ahead and create an HTable. Pass in our configuration and our table name. And we need to specify, remember we're creating HFiles, so we need to specify our HFile output format, and we need to configure incremental load job table. This is pretty much just like boilerplate code at this point. And we need to specify, we need to tell it where we are reading from. So that would be add input path, and we need to specify where we are writing to. Set output path, job output path, and just wait for completion. So this driver is, it's pretty generic. You might be using copying and pasting this code across a lot of your different bulk output scripts. It won't change very much, so the bulk of the new information would be in this HBase Mapper. So let's go ahead and write that. Again, I'm going to copy and paste some of the imports that we'll be using. And let's see, HBase Mapper extends. So we need to extend a mapper, which is the MapReduce mapper. Long writable, text, immutable bytes writable, key value. Cool. And I'll explain those in a second. And all right, so we need to actually, Mapper has a couple different abstract methods that we need to override in order to implement a MapReduce job. The ones we're going to override are protected void setup. So this will be run before the job is about to start. You can do various, setup things if you need to create some objects or stuff like that, whatever you need to do. And the bulk of the code will be going into this map function. So that's what we really need to work on. Text value, context. Cool. And these will pretty much look the same. So this map is based on how we extended Mapper. This text value is actually what is going to be like a single line of the CSV file. And this key, not too sure about yet, but we'll see if we have to use it. Cool. So a single line of each of the CSV files is going to be passed into this map function. So it's going to read a line in, and then it's going to pass it in, and we need to parse that, and we need to somehow create a HTable format out of that. So the first thing in the CSV file, which we saw before when we looked at the schema, is that the first line is basically information about the file. It's stuff like the various headers. So we don't really care about that data. Like, we already know how it's structured, so we don't actually want to parse that information. So we can just add a simple if statement here. Medallion greater than -1 turn. So we are basically skipping the header of the CSV file just to make sure that we don't run into any errors whenever we try and parse it. So let's just go ahead and create a string array to hold our fields, and we are going to take this line that we read in, put it into a string, and split it by the comma. You can use a more fancy CSV parser if you need, but this is all that we need here. And let's go ahead and just print the message if we do actually fail at any point. Cool. So if remember when we looked at the trip data and fare data, they had a different amount of fields. One actually, I believe, had 14 and one had 11. So we can use that information to basically write one bulk upload script for both files, basically based off of the field length. A little bit janky, but it works for us. This is just a simple script. So fields.length equals 14. We know that this is trip data. And if it is 11, we know that this is fare data. Okay, so let's go ahead and run. Okay, so let's go ahead and write the code for the fare data first. Remember, medallion was field 0. Actually, it's getting a little bit fuzzy on which what the fields are. So let's just go ahead and take a look at our CSV files again. So mount temp. Of course, I deleted the files, so we're gonna have to grab them. HBase data trip fare 1.csv. So we're just basically pulling it back out of HDFS just so we can take a look at what the CSV file looks like, just so we don't mess up when we're actually writing our scripts. And looks like we got disconnected. Okay, so that worked. So we need trip data and cd temp. Okay, wait for us to retrieve this data from HDFS. Not the fastest thing to do. I guess we can go back here and work on this. So our our medallion, I believe, is always the first field. Cool. So this is done. So if we do, what are we going to work on? We're going to do trip fare or fare data. I think we're doing trip fare first. Cool. So we have medallion, hack license. Okay, so now we know the correct indexes. So pickup string, that's 0, 1, 2, 3. And we want, let's store fare amount also, I guess. So that is the 5th one. And we need to convert this string into a date. So let's just go ahead and do pickup date equals null and try and convert it. Okay, in order to do that, we need to have a date format. So it looks like the date is year-month-day and then time information. So let's just do a simple date format. And year-month-day and hour, minute, second. Okay, so here we can just do date format dot parse. Okay, and then catch. Okay, if we ever fail to parse the date, just print the message and return. Okay. And then we need to convert this date into a timestamp, since that's actually what we're going to be storing in the database. Pickup date, timestamp, get time. That's how we get the epoch time from a date. Okay, now that we have our data, we can get on to the good stuff, which is actually storing that in the H file. So we actually need to create a couple more global variables here. We need to have our key value, and we need to have our immutable bytes writable H key, which is the RowKey, which corresponds to immutable bytes writable key value. Okay, so we can do H key dot set. So we need to set our RowKey. And I think we talked about this in tutorial number 4 about our RowKey, that we were going to use the medallion and the pickup date time as kind of a unique identifier. So let's go ahead and set that. We're going to use this useful bytes class that HBase has, because everything they store in HBase is stored as bytes, so we need a lot of conversion functions. So we're going to use this bytes class for that. So let's go ahead and create our key as a string, and then we convert it to bytes. So we have a S for the medallion ID, and we have D for the timestamp. Medallion timestamp. And we format it as a string, then we convert it to bytes, and we set it as the RowKey. And we need to now add each of those column values to this specific RowKey that we've created. So we can just create a new key value, give it the RowKey that we just created, and we need to give it the byte value of the column family. So we can do bytes.toBytes. Remember, in the previous tutorial I said the column family is going to be D. And we need a specifier for the column name, so for medallion. So let's just go ahead and use M, really short. Always want to have it short for HBase to save time. And we specify the timestamp of when we do an insert. This is good just for HBase if we ever want to do range scans based on timestamp. And we actually want to store the actual value. So again, RowKey, column family, column name, timestamp, and the actual column value. And that's how you create a key value. And then we can do context.write, which will write this RowKey key value pair to the H file. And we can do the same thing for fare and pickup date time. Let's go ahead and copy paste this. So D is the same, so this is F. And let's just call this P for pickup date time. Timestamp, so this is fare amount string, and then pickup string. Actually, we want to do timestamp. Cool. So this actually all looks good. We can do the same for trip data, but for now I guess the one thing we're interested in finding out is, what is the medallion that has the largest fare? So we can write this part later. Pretty much going to be exactly the same as the fare data. If we take a look at, man, this thing keeps timing out. Gonna have to get a better console window because this bash shell is a little bit messed up. Okay, we'll wait for that to time back in, and we'll be right back. Okay, we are connected again, so let's go ahead and cd into mnt temp trip data. So if we ever wanted to use stuff like trip time in seconds, just all these other cool fields, we can add the import for that CSV file, and all we have to do is just specify the fields the same way that we did with this. Specify the key values, and the row key would pretty much be exactly the same. So this is if we want to have more complex queries like that access multiple different data sources, but we're really only concerned with fare amount right now. So this should be it for the bulk upload scripts. So now we need to actually upload this stuff into our server so that we can compile it. So I'm going to go ahead and have this management console here, and I'm going to zip up. Let's see. We're going to zip it up, upload it, and then copy it over into our folder on the server. So let's do bulk zip, and then we're going to unzip it and compile it. So let's see where we see tutorials. So this should be very quick. Cool, that's done. So now we can copy it out. Let's see, where do we want to compile this? We can just compile it in temp as well, I guess. So AWS S3 CP, S3 quackware, New York City taxi data, bulk.zip, and let's copy it out into bulk.zip here. So unzip this, cd bulk. Cool. So now we have pretty much what we just wrote here is now available on our server. So in order to compile it into a jar, all I have to do is do maven clean install. Interesting. Oh, I have to reset my path file because I exited out, and path equals path, and then what was it? User local Apache Maven bin, because I exited out of the console window and I didn't actually set it in my .profile or .bashrc, so it got overwritten. Cool, so we can do maven clean install now. So this will, parse our POM, download all of our dependencies, which you get a ton of them, and it'll compile our jar files, and hopefully everything will work out. And if there are any errors, we can go ahead and take a look at them and fix them. Awesome, so there are an error. Bulk import driver, cannot find symbol. Okay, so let's go ahead and take a look at these. 26, table name. Oh, yep. There's an error already. So let's go ahead and edit this directly on here so that we don't have to deal with copying the stuff over again. C driver.java. Conf. Hopefully this is the only mnt temp. Hopefully that's the only error that we have. C bulk. Let's see. And another. Can I override setup? Let's see what's wrong with this one. Setup context. Okay, looks like I was throwing exception rather than IO exception. So source main Java and HBase Mapper. We didn't even do anything in this setup, but it still yells at us. Okay, let's go ahead and install that. So you'll probably run into these errors if you kind of write it right like that. Just things you just have to fix. 'Tis a learning experience. Cool. Looks like it's all done. Awesome. So now in our target, we have this jar file that we can run against the CSV files that we have in the CSV files that we have in HDFS. Okay, so in order to actually run that, what we can do, so in order to actually submit our MapReduce job, we can use Hadoop jar, specify the jar file, which in this case is New York City taxi bulk import snapshot.jar. And then we have to specify the class name of the driver, which is com.quackware.NYCTaxi.bulkimport.driver. We can specify any dependent jars that we have, which we have none since we are only using the HBase and Hadoop jars. And then we have to specify the input and output files. So the input file is home. I believe it's, let's see, let's take a look at this. Hadoop Festus LS. Just to make sure that we have this right. Might be user. Yep, that was it. And ours is actually -HBase data. Cool. Trip. Let's see, which one did we do? We did fare data. So trip fare one.csv. So that's our input. Our output, let's just call it /output2, or just output2 without the slash. And our table name is just fare. All right. Moment of truth. Let's go ahead and run this. Let's see what we got. Looks like our MapReduce job is now running. So let's start checking on, see if this has created the output 2. Nope, not yet, but it is working. So this will probably take about a minute or so to parse that ginormous CSV file. And it's going to create the HFiles from it, and then we can then run the incremental loader on it. And hopefully we do not have any errors. So I'm going to go ahead and pause this while this runs, and we'll get back to you when it's done. Okay, so it looks like our MapReduce job has completed successfully. So now we just have to find where that output file actually is. So let's just go ahead and do an ls on the home directory, and I believe it is stored in user Hadoop. It's user Hadoop, yep, output 2. And if we look inside output 2, we should be able to see the D column family. Cool, D column family, and inside that should be the H file. Cool. So what we did was we read the CSV file from HDFS, we formatted it into the H file format that HBase can now read, and we stored that into HDFS as well. So now all we have to do is just point the load incremental H files class to this H file here. This is something that HBase has built in, not something we have to write ourselves. Awesome. So in order to actually execute that, we just have to do HBase org.apache.HBase MapReduce. This is, again, I don't know if this is a MapReduce job or what is actually inside of it, but it does exactly what we want. Load incremental H files, output 2, and specify the table name. So let's go ahead and run that. Org Apache HBase. Nope, missed one. Org Apache Hadoop. HBase, super long package names. All right, looks like it is working. Oh, I wonder if it worked already. So let's go ahead and run HBase server and run a scan on fare to see if, or sorry, HBase shell. And run a scan on fare and see if the data was actually loaded in. Awesome. So as you can see, if I can kind of expand this a little bit, we have our various, this is our, medallion ID, and this is the date times, and there's the fare. So this one was like a value of 8. Cool. So we have all of our data is now stored in HBase, in an HBase table that we can query off of. So that's it for this tutorial. We wrote our bulk upload MapReduce and ran our incremental loader. Of course, you can change this to do any field that you want that you're going to be used with your MapReduce script. So we're going to take a look at that next. Thanks for watching. Make sure to watch the rest of the tutorial. This is Quackworth signing out.